In this example, we see we have a couple of values for sine and cosine for different angles, and we're looking to find the value of sine of x plus y and the cotangent of x minus y, so two separate examples here in one. We know that the sine of some angle x is 12 over 13, while the cosine of some other angle y is negative 3/5. But we do know that both of these angles reside in the second quadrant. So if you'd like to go ahead and try to find these values first, pause the video and do so, and then come on back and we'll work it together. Well, to begin, if I know both of these angles are in the second quadrant, what I'm going to go ahead and do is draw the second quadrant, and I'm going to go ahead and draw these angles up into the second quadrant. So here I have this angle, and of course this angle, and this guy will be x, and this guy will be y. So we always draw our triangles down or up to the x-axis. So here's this right triangle, and here is this right triangle. And of course this little angle that we'll be using is this critter down here. Okay, so we know that the sine of x is 12 over 13. So sine is opposite over hypotenuse, so 12 over 13. And when we go up, with running parallel to the y-axis, so this 12 will be positive, but this leg over here coming to the left along the x-axis will end up being negative. But negative what? Well, we can recognize that this is a 5, 12, 13 right triangle, or perhaps you would like to use the Pythagorean theorem. Either way, you're going to end up with 13 squared, which is 169, minus 12 squared, which is 144. We'll give you 25, and the square root of that will be 5. All right, so that's the completed triangle for x. And so how about for y? Well, we know that the cosine of y is going to be negative 3/5, and cosine is adjacent over hypotenuse. And once again, we know this 3 is going to be negative because we're running down the left side of this x-axis, and then working our way up, this will be positive. And you can see this is a 3, 4, 5 right triangle, or again you could use the Pythagorean theorem to kind of get that third value. So we have our completed triangles here, and they're in the second quadrant. So we'd like to go ahead and start by using the sum identity for sine, so the sine of x plus y, and we have our angles x and y here and here. So we will be employing both triangles. So for the sine of x plus y, we know that this identity is going to be the sine of x times the cosine of y plus the sine of y times the cosine of x. Okay, we'll just move up a little bit here to make some room. So the sine of x, actually, come on back down a little. The sine of x we know already, that was given to us. And the cosine of y, we know that already, that was given to us. So we can go ahead and put those in. So the sine of x is 12 over 13. And the cosine of y is negative 3/5. And then plus, all right, now let's make some room. So the sine of y, okay, so here's our y triangle. So the sine is opposite over hypotenuse, so 4/5. And we're going to multiply that by cosine of x. So here's our x triangle, and cosine is adjacent over hypotenuse, so negative 5 over 13. So we just need to figure out what this will evaluate to. So when I multiply these first two fractions, it looks like I have negative 36 over 65. And to that I'll add this product, so 4 times negative 5 is a negative 20 over, and we have 65 again, because 5 times 13. So we're adding a negative, so it's a negative and a negative, so we have negative 56 over 65. And that will be the value that I get for this sum identity for sine when I go ahead and add these two angles up and then take their sine. Okay, so we're going to do one more. We're going to do the cotangent, and we're going to use the difference identity. So cotangent of x minus y. So another way you could view this is 1 over the tangent of x minus y, or just the reciprocal. Well, we know and I'm going to write this down here for us. We know that the difference formula for tangent is going to be the tangent of x minus the tangent of y over 1 plus tangent x times tangent y. Okay? But we're not doing tangent, we're doing cotangent. So what we could do, because tangent and cotangent are reciprocal functions or reciprocal identities here, we can just take the reciprocal of this. So we will actually be looking for 1 plus the tangent of x times the tangent of y over their difference. So the tangent of x minus the tangent of y. And that will ultimately give us this difference identity for cotangent. So we just did the tangent and took the reciprocal. Okay? Easy peasy. So let's go ahead now and find these values for the tangent of x and the tangent of y. And we'll go ahead and write them down here so we kind of have them. So the tangent of x and the tangent of y. So let's go find them. Okay, so using the x, tangent is opposite over adjacent, so 12 over negative 5, or you could write that as negative 12 fifths. Okay, so how about the tangent of y now? The tangent of y, again, is opposite over adjacent, so 4 over negative 3, or you could say negative 4 thirds. Okay, so we have our tangent of x and we have our tangent of y, both of these values which we will be using here in our formula. So 1 plus, and we're going to multiply them together. So negative 12 fifths times negative 4 thirds over, and then we're going to subtract them. So negative 12 fifths minus negative 4 thirds. So at this point, it's just kind of time to figure out numerically what this equals. So here we go. We're going to multiply these two in the numerator. We see that negative times a negative will end up being a positive. So it's 1 plus, when I multiply, it looks like 48 over 15. And so our denominator, when I subtract this negative, I can do a little swoosh swoosh. And so it's going to be negative 12 fifths plus 4 thirds. Well, I kind of need to get common denominators here. It looks like there'll be 15 for a common denominator. So I multiply the first one by 3 over 3, so negative 36. Multiply the second one by 5 over 5, so 20 there over 15. And so when I add these, it looks like I'll have negative 16 fifteenths. So negative 16 fifteenths for the sum of these fractions. Okay, so let's make this 1 here really like a 15 over 15 to get these common denominators. So 15 plus 48 will make 63 over 15 over negative 16 over 15. For our complex fractions, this division by a fraction is really multiplication by the reciprocal. These 15s cancel, which is really nice, so this negative will come up. Negative 63 over 16. So this will be the value that we have for our difference identity for cotangent. And once again, all of this was given the information that the sine of x was 12/13, the cosine of y was negative 3/5. We knew both of these angles were in the second quadrant, and we were able to find these two values, the sum identity for sine and the difference identity for cotangent. And those values, once again, were negative 56 over 65 and negative 63 over 16, respectively.